Good day, everyone. In this video, we are going to look at experiments and some types of studies. This is just going to be a real brief overview or an introduction to these ideas, mostly because these are things that we are not going to be doing as a student. This would be something that does take a lot of preparation for and a lot of careful details that need to be taken care of. But we still want to kind of understand what the statistician part of their job is when we are taking a statistics course. This one is going to be talking about the different types of experiments and things of that nature. So first of all, there are two basic types of things that happen. We do have something called an observational study. And in this type of study, they usually observe just different characteristics from the sample. They may take measurements at certain times. They may retake measurements at certain times and just gain some data to kind of learn about what's going on with the whatever population they're talking about. Um, a lot of times they don't do a lot of manipulations to their samples. In other words, they aren't going to be administering different types of drugs or things of that nature. They're just going to watch or observe what's happening over time or going back in time and just kind of trying to get a feel for what the situation is. When you're doing an observational study, considering we are not doing a lot of manipulation, we have to make sure that we do get a good sample, some that is a good representation of our population. And we will talk about in a different video the different ways we can select a sample. So that would be something we would have to be very careful about because we want to make sure that our sample covers all the different types of groups in our population. An experiment is a little bit more detailed. And you think about it, an experiment, we're actually going to be conducting a survey and looking at how someone reacts to something. So we're going to be changing conditions. We will be, I'm going to say, manipulating a person, whether it be having them try something different, using their left hand versus their right hand, testing a different type of drug, um, trying to do something blindfolded versus not blindfolded, whatever we are going to be doing, we're going to be looking at how a response changes when we change those conditions. Uh, the person that is carrying this out, we have to be a little bit careful to making sure that everybody is kind of random in these um, situations because we don't want personal influences to get in the way. So here in the experiment, we want to make sure if we have two different groups that these groups are pretty evenly based. So like the same number of men, same number of women, same number of people of color or certain ethnicities. All of those things we want to make sure are comparable when if we have two different groups, like maybe someone getting the drugs and someone not getting a drug, or someone using this type of golf club versus this type of golf club. So we'd want them to have the same type of scores. We want like all our weaker ones to be doing this kind of thing, and all the better players to be using this. We want them to be kind of even. And within those groups, we'd also want to make sure to cover all the bases that we would need too. So experiments are a little bit more detailed that way, um, making sure that our groups, or however many groups we have, are comparable to each other. So first of all, just trying to determine if things are an observation or an experiment. In a well-designed observational study, we basically select our sample to be a really good representation of everybody that's in our population. So again, making sure we have women and men or whatever our population is. If we were doing different like manufacturing, we'd want to make sure to get some from all of the different lines that we may have, production lines, or all of the different If we have different people working at different times, we'd want to get groups from every single time as well. So we want to make sure that everything is generalized to get that whole population being represented. Okay. An experimental study, again, we want to make sure that things are done really, really well because we'd like to be able to show some sort of cause and effect. And if things aren't done well, we can't usually say that this thing caused that thing to happen. So we want to make sure everything is really, really well done. This is going to make sure things are very, very random. So a lot of times when we're doing studies, we try to manipulate one thing and see how it causes something else to react. The thing that we are kind of using as our manipulator, a lot of times we'll call that the independent variable, also the predictor, the explanatory variable. It's the one that's going to explain the responses. The affected variable, the thing that outcome, that's going to be our dependent variable because it's also going to be responding to that independent variable. A lot of times, like I said, the independent variable is that manipulator, that manipulated piece, and the dependent kind of shows what happens when we do that. And we will talk about those things later in other videos as well. When we're doing studies, there's something that we call a confounding variable. Those are things that are there that we really can't get rid of. And it's hard to do that. Sometimes there's a lot of confounding variables that are it's not possible to show cause and effect. Some of the confounding variables that are out there is a person's beliefs or our attitudes, if we're talking about how drugs react, our gene pool, where our mothers and our fathers, where we came from, our ethnicity, sometimes being white or black, that can have an effect on how certain treatments can affect us based on our genetic makeup. So those are confounding variables that we just can't get rid of. I mean, you can't change who you are. So those things are there. And sometimes we have to make sure that when we do an experiment that we remember that these things are there and that we're looking at those as well and trying to get them to not play a part of the cause and effect sort of thing. We do have other types of studies, whether they be experiments or just observational. Something, if we look in the back, go into the history and go back to someone that's kind of a retrospective. That's kind of what the word means, is to go back and see what happened in the past to maybe have brought this to light. Or, like they might ask you questions about what did you eat last week, Friday, things like that to maybe have caused the onset of whatever it is that happened. A cross-sectional, they're going to be taking pictures, like right now, what's happening right now. Just kind of looking at here we are today, and looking at a whole bunch of people and what's happening right now in that current population. A longitudinal study is going to be someone who goes and follows you from year to year to year into the future. So kind of looking at you now and then say, okay, in 5 years, we're going to see how you're doing. Cancer patients are someone that they do a lot of this with because they will look at, when they were first diagnosed, then as it goes on, what happens after this treatment, what happens after that treatment, what do the things look like down the road? So those are participants that are a lot of times over time, if they're in any type of drug studies, these would be longitudinal studies. Some other terminology that goes along with any of these cases, mostly in experiments, because experiments, again, we will have different groups that we can compare one group to another group. Maybe the people getting the drugs, the people not getting the drugs, the people getting twice the amount or different levels of the drugs. Those different groups are a lot of times referred to as a treatment group. So you would be like the no drug group, the 5 milligram group, the 10 milligram group, or maybe we're doing exercises, the no exercise, the exercise in the morning, the exercise in the afternoon groups. The experimental unit is the individual thing that we're experimenting with. So in those cases, I was giving the individual person that is in that group. So the person actually getting the medication, or the person actually doing the exercise in the morning or the afternoon, or not doing the morning. The factors are the things that we are looking at. So with the drugs, maybe we're trying to figure out how long a headache will last if you have no drugs, 5 milligrams, 10 milligrams. The factor would be those times. The levels would be the different levels that we give of those drugs. So just some terms that go into those experiments. Okay. A control group, first of all, there is a slight difference between these two terms, control group and placebo. A control group is someone who gets the status quo situation. So it may be, if it's an exercise, maybe they're the ones that don't do any exercise. They're doing what the normal person does, just walk to work or whatever. Or there maybe you're trying to see if a new label will work, and so you put the old labels on some of our cans and the new labels on the new cans. The old labels would be the control group because we want to see if this new label changes things. Versus a placebo, a placebo is when we are giving a treatment that really isn't a treatment. A lot of times people refer to this as a sugar pill. So you're getting a drug, but this drug really has no effect on your body or anything. So a lot of times they do placebos in drug testing because the mind can play a lot of a role in things. And if you think you're getting a drug, sometimes you can make yourself better. The mind is very powerful. So sometimes the mind can make you feel better. So they want to make sure that what they're getting results, that it isn't due to this, what they call a placebo effect, which is getting better because you're taking a medication. They want to make sure you're getting better because of the medication. So hence the reason they will do a lot of placebos in drug medication type studies. Single blind versus double blind. The single blind means the person getting these drugs don't really know anything. And that's most of these studies. If you're in a lot of them, you're not really sure what treatment group you are in, because again, we don't really want to know. That person doesn't necessarily want to know or shouldn't know, because again, the mind can change things, and our attitudes can change things. So not knowing what group I'm in would be a good thing. A double blind is when I don't know what group I'm in and the person giving the medication does not know what group they are in. So, or those two immediate people are not aware of what group they are in. The reason for that is because if a doctor starts to see benefits from one group versus another group, he might be swayed to talk about or disclose some of the results he's seeing to other people, which can cause effects within that study. You also could have that the doctor does know, but maybe the statistician isn't real sure. But someone has to keep track of who's getting what. So usually, a lot of times, the people who are getting things don't know, but someone knows who's getting what. Otherwise, the data would be useless. because we need to be able to attach what you're getting with what your results are. Okay. These next few things are going to be kind of talking about the designs and how we, well, they're just the way we design some of these pieces. So a completely randomized design is when we have, let's just talk about drugs, and John comes in, he's getting drug A, randomly pull out of a hat which group he's going into. So we're just going to randomly throw people into groups. That would be a completely randomized design. A block design is making sure that we take, like if we somehow sort these people and making sure that every block is kind of covered. And this is a little bit better because we can kind of make sure that the groups are more comparable to each other, making sure that we have, you know, the different ethnicities or the different races within the groups, if that is something that we are trying to study, or the different genders. So sometimes a block design is a little bit better than just a completely randomized. Sometimes we have designs that will, let's say we're trying to do maybe testing a type of fertilizer. So a completely randomized design would be putting fertilizers completely randomly on different plants within a field. That would be very difficult to do. A block design would be like maybe taking every field that this farmer has and doing every outer row from those pieces. So we could get different types of soils and different types of situations. So again, we would be kind of making sure that the different soil types are being tested, the different lights are being tested, the different water categories are being tested by being a little bit more specific on how this is designed. Repeated measures is when we kind of want to do this test more than once because we want to make sure that the results we get aren't a fluke. So a lot of times they will do a study and then they will do it again on a different group of people. Or maybe they'll even do it on the same group of people, but getting different, just making sure that doing it repeated times, because I want to make sure that those results are going to happen for sure. And the more times you would repeat this test, the better. It's kind of like when you study something, you know, I studied it. Yes, I got it. I got that problem right. But if I did it again, would I get it right again? You know, so the more times you do something, the better you're going to be at that, and the more likely the results would be the same. So that's the reason for the repeated measures. Hopefully, this gives you just a quick overview of the different types of designs that are out there. Some things to kind of note, though, when you're doing an observational study versus an experiment. Observational studies, we're just kind of observing what's happening. We're not, I mean, we're taking notes, we're getting the data, but we aren't doing a lot of manipulating. Like we might say the temperature today is this. And then again, the temperature tomorrow is this. And if the temperature was this, we had this many people doing that. The temperature, when we measured a couple different things, like the temperature versus how many people were riding bikes, you know. And we can't really say in the long run, we can observe, boy, when it was warmer, there were more people riding bikes. We can't say then that the warm weather causes people to ride bikes because it wasn't a experiment. When we do observational studies, we cannot prove cause and effect. You have to have very well designed experiments in order to say something causes something else. So again, just a really quick overview of experiments and different types of studies and some of the terminology that goes with them. I hope that you have enjoyed watching my videos. And I'm hoping you're enjoying learning a little bit more about statistics and all of that wonderful fun stuff. So I will see you hopefully in the next video.